Yeah, welcome again to the lesson of today. We are very interesting to welcome you to our session today. And of course, the last time we covered a lot of materials, and the aim of the lesson of today is to find or to determine dimensions of the physical quantities. This concept comes from the dimension analysis, the way of relating physical quantities by using the basic fundamental physical quantities. So it is very important and very interesting lessons today. So of course, we can say that when we are talking about the basic fundamental physical quantities, we mean mass, length, and time. So these are three basic fundamental physical quantities which are used to determine the dimensions of the other physical quantities. Something to understand in this lesson is that we say we have this bracket. This bracket means dimensions of. Dimensions of. So if you see this bracket means dimensions of. So for example, we say dimensions of mass. Dimension of mass is m. Dimension of length is L, and the dimensions of time is T. So these are very important concepts. So we are going to use the basic three fundamental quantities, which this mass, length, and time, to determine the dimensions of the others. For example, here you may find in our questions here, what is dimensions of volume, density, and velocity. So we can say now solution, we are starting dimensions of volume. Dimensions of volume. Dimension of volume means volume is equal to length times length times length. So is equal to dimension of length times dimension of length times dimension of length. So finally is equal to length times length times length, because dimension of length is L, dimension of length is L. So finally you can get the dimension of volume. Dimension of volume now is equal to L cube. So this is how we can get the dimensions of volumes. Then we continue again. Number two is dimensions of density. Dimension of density. Dimension of density means is equal to dimension of mass divided by dimension of volume. Dimension of mass divided by dimension of volume. So dimension of density, dimension of mass we know is m. Dimension of volume now is L cube. So finally the dimension of density, is equal to mL times -3 exponents. So this is how we can get the dimensions. And the another is also dimension of velocity. Dimension of velocity, number 3, velocity. Velocity, we know dimension of velocity. Velocity is equal to length over time. So it will be dimension of length over dimension of time. So we may say now dimension of length is L, dimension of time is T. Now dimension of velocity, is equal to LT times -1 exponent. So it's very important concept to understand the concept, the basic. We are talking about mechanics now. These are very important physical quantities which are used to determine the dimensions of the others. So this bracket means dimension of. So dimension of mass is m, dimension of length is L, dimension of time is T. So this is very important. So if you are asked, for example here, what is dimensions of volume, density, and velocity? We know that the formula for finding volume is equal to length times width times height, but height and width are termed as the length. So we say volume, dimension of volume is equal to dimension of length times length times length. So this is equal to dimension of length times dimension of length times dimension of length. Finally, you can get dimension of length is L, dimension of length is L, dimension of length here is L. So final dimension of volume is equal to L cube. L cube. That is the same when you come to the density. Density is equal to mass over volume, of course. So if you ask you to find the dimension of density, we say dimension of density is equal to dimension of mass over dimension of volume. Dimension of mass we know is m from here. Dimension of volume is L cube, as we found here in the previous question. So we can get now m over L cube. So this, if you take it above, you may find m is equal to L times negative 3 exponents. So this will be the dimensions of density. When you come to find the dimension of velocity, we know velocity is equal to distance of time, but distance is termed as length, of course. So dimension of velocity, we say is equal to dimension of length over dimension of time. So dimension of length is L, and dimension of time is t. Now, finally, you can get the dimension of velocity is equal to LT times, LT times exponent negative 1. So this is how we are going to do these important materials. And what is very important to understand, this is dimensional analysis. Thanks.